welcome back to Amruta's Blink. I am Amruta Kulkarni. Today we are going to discuss problems on mixtures and alligation. Alligation, practice problems on mixtures and rules of alligation. Alligation is a concept used to solve problems related to mixtures. Alligations help us to determine the ratio in which two substances need to be mixed to arrive at the consistency of the final mixture. In alligation, the concept of mean price is used. Now, what do you mean by mean price? Mean price is actually the cost price of the unit quantity of the mixture. Rule of alligation says if two ingredients are mixed, then quantity of cheaper upon quantity of the dearer is equal to cost price of dearer minus mean price whole divided by mean price minus cost price of cheaper. As of now, just remember this formula. Whenever we will be solving the problem, you will be able to relate what this formula is all about. We'll see problem number 1. In what ratio must water be mixed with milk to gain 25% on selling the mixture at the cost price? Now, this problem is exactly application of the formula which we have just seen. Now, what is that formula? The formula says quantity of cheaper upon quantity of dearer is equal to cost price of dearer minus mean price whole divided by mean price minus cost price of cheaper. Moving back to the problem. Now, in this problem, what is being asked is in what ratio must water be mixed with milk to gain 25% on selling the mixture at the cost price? 1:2, 1:4, 1:5 and none of these. Now, in this problem, cost price of milk is not given and even selling price is not asked. We just need to calculate the ratio, and what is given is what we need to earn on selling or earn on cost price is 25% of profit. So suppose if your cost price is 100, then you need to sell the mixture as rupees 125 so that you will earn 25% of the profit on your cost price. Now, in this case, as of now, let's assume that cost price of the milk is, let's say, rupees 1 per liter. Now, we are mixing water into this milk. Let's say this water is available at free of cost. Hence, cost price of this water, we can assume that cost price of this water is, let's say, rupees 0. So, cost price of rupees milk is 1, and in this milk we need to add water in order to get profit on that, and cost price of this water is absolutely free and it is, hence cost price is 0. Now, we need to gain 25% on this cost price. So, suppose cost price is 100, then your selling price should be equal to 125. So, let's say your ratio of selling price to cost price will be 125 upon 100, that is 5:4. Now, if we apply the rule of alligation, let's say in first column there is water and in another column there is milk. Then in the second row, that is here, what we will do is we will write the cost price of both. Now, cost price of water is 0 as well as cost price of milk is 1. Now, what should be the selling price of this mixture? What should be the ratio? This ratio is 5:4, which we have just calculated from here. Now, what we will do is we will find out the difference in order to apply the formula of alligation. So, here if you form a cross, then in this column what you will write? You will write 5/4 minus, so this 5/4 minus 1 is equal to 1/4, and for this column you will apply the formula in this way. that is 5, this 5 by 4 minus 0 is equal to 5 by 4. So you have obtained this 1 by 4, that is 5 by 4 minus 1 by this formula, and 5 by 4 minus 0 is equal to 5 by 4. Now we will find out the ratio of water to milk, that is 1 by 4 as to 5 by 4, which is equal to nothing but 1 as to 5. So in what ratio water must be mixed with milk? Now water has to be mixed with milk, so in first column we have written water. Suppose in the question would have been asked that in what ratio milk must be mixed with water, then in first column we should have written milk. So now your ratio should be 1 as to 4 divided by 5 as to 4, 4 cancel, so your required ratio is 1 as to 5, and hence your answer is option number C. So here, this is a direct application of rule of alligation. I hope you have understood now what is the formula of rule of alligation. We'll move to another problem. In a glass of milk, the proportion of pure milk and water is 3 as to 1. How much of the mixture must be withdrawn and substituted by water so that resulting mixture may become half pure milk and half water? Now in this problem we cannot directly apply the formula of rule of alligation. This problem we will solve conceptually. Options are given: 1 by 4, 1 by 3, 4 by 3 and 1 by 2. Now first of all we will understand the problem. In a glass of milk, the proportion of pure milk and water is 3 as to 1. So suppose you have one glass which has a capacity of 4 units. Now in this capacity of 4 units there are 3 parts of milk, that is 3 units of milk and 1 unit of water. So as of now, initially your glass contained 4 units of mixture. In this 4 units, it is given that by this 3 as to 1, quantity of milk is 3 units and quantity of water is 1 unit. Now moving to next part of the question, how much mixture should be withdrawn and substituted by water so that resulting mixture may become half pure milk and half water? So suppose it is being asked that how much of the mixture must be withdrawn. So let's assume that X units must be withdrawn from the mixture, and again that X units are replaced with water. So initially out of 4 parts there were 3 parts. So whenever you are withdrawing X units, actually how much milk will be remaining in that mixture, because when you are withdrawing X units of mixture, actually you will be withdrawing 3x upon 4 units of milk, because when there are 4 units of mixture, in that 4 units of mixture there are 3 units of milk. Now suppose you are withdrawing X units of mixture, so obviously there will be 3x upon 4 unit of milk. So remaining milk in that mixture is, originally there were 3 units, so 3 minus 3x upon 4, that is 3 4s are 12, 12 minus 3x upon 4. Similarly, we also need to calculate the quantity of water. So initially there was 1 unit of water as given here. So when you withdraw X unit of mixture, actually how much water is withdrawn? That is X upon 4. So remaining water is 1 minus X upon 4. But whenever you are withdrawing X unit of mixture, what you are doing is, this mixture is replaced by X units of water. So quantity remains same. So hence now revised quantity of water in that mixture is 1 minus X upon 4 plus X, because X units of water is additionally added. So now if we simplify this, 1 minus X by 4 plus X, LCM is 4. So 4 minus x plus 4x minus x plus 4x is 3x plus 4 as it is upon 4. Now moving back to last part of the question, resulting mixture may become half pure milk and half water. So if there are 2 units, then there will be 1 unit of milk and 1 unit of water. Hence we can say that the quantity of milk and quantity of water in that mixture is equal. Hence we can say that 12 minus 3x, that is this quantity 12 minus 3x upon 4 is equal to 3x plus 4 upon 4. Now we can cancel the denominator as it's same. So 12 minus 3x is equal to 3x plus 4. I have just reversed LHS and RHS. So 3x plus 4 is equal to 12 minus 3x. 3x plus 3x, that is 6x, is equal to 12 minus 4, that is 8. 6x is equal to 8, and hence x is equal to 8 upon 6, that is 4 upon 3. So this x, now what is this x? X is a unit of liquid to be replaced with water. And what is being asked in the question, that is how much of the mixture must be withdrawn. So this x is exactly our answer, that is 4 by 3 units are to be withdrawn and replaced with water, so that resultant mixture will have equal amount of milk and equal amount of water. I hope you understood this problem, because this is a core concept of alligation. So answer option C, 4 by 3. Moving next to problem number 3. 2 vessels A and B contain milk and water mixed in the ratio 5:2 and 8:5 respectively. Find the ratio in which these solutions are to be mixed so that new solution contains milk and water in the ratio 9:4. 2:7, 1:2, 7:2, 2:1. Now there are 2 vessels A and B. Both the vessels contain mixture of milk and water, but one mixture, that is vessel A, has milk and water ratio 5:2. So suppose there are total 7 units. So out of 7 units there are 5 units of milk and 2 units of water. Similarly, in vessel B, if there are 8 plus 5, that is 13 units, you have 8 units of milk and 5 units of water. Now we will create a table. So let's suppose you have vessel A, which has total 7 units, in which milk is 5 units and water is 2 units. Similarly, for vessel B, when there are 13 units, 8 plus 5 is 13. So out of which there are 8 units of milk and 5 units of water. Now what is being asked in the question is find the ratio in which these solutions are to be mixed so that the resultant contains milk and water in the ratio 9:4. We'll assume that ratio is x:y. Now what do you mean by this ratio is you need to take x unit of mixture A plus y unit of mixture B. So how much will be your total quantity of the mixture will be x plus y, where x is a quantity of A, quantity of mixture from vessel A, and y is a quantity of mixture from vessel B. Now when we say that there are x units of A, so we know that in vessel A there is 5 units of milk out of 7. So if you take x units of A, it will have 5x upon 7 units of milk, and similarly 2x upon 7 units of water. Similarly, if we take y units of B, then it will have 8y upon 13 units of milk as well as 5y upon 13 units of water. So total, when we take x units of A and y units of B, total quantity of mixture is x plus y, and in this x plus y, quantity of milk will be equal to 5x upon 7 plus 8y upon 13. Similarly, quantity of water will be 2x upon 7 plus 5y upon 13. And now this ratio is given as 9:4. So we can create the equation as 5x upon 7 plus 8y upon 13 whole divided by 2x upon 7 plus 5y upon 13 is equal to 9/4. Now LCM of this 13 and 7 is 91. So in the numerator we have 65x, that is 13 into 5, 65x plus 56y upon 91 whole divided by, again LCM of this 13 and 7, 91. So in the denominator we have 26x plus 35y upon 91 is equal to 9:4 as it is. Now we can cancel out this 91. So we will have 65x plus 56y upon 26x plus 35y is equal to 9/4. Now by cross multiplication we will get 260x plus 224y is equal to 234x plus 315y. So now 260x minus 234x is equal to 26x. Similarly, 315y minus 224y is equal to 91y. So we have 26x is equal to 91y, that is x upon y is equal to 91 upon 26, that is nothing but 7/2. And this x as to y is our required answer, that is 7:2. Now what do you mean by this answer is you need to take 7 units of mixture from vessel A and you need to mix it with 2 units of mixture from vessel B, so that resultant mixture will contain milk and water in the ratio 9:4, and hence required answer is 7:2, that is option number C. We'll move to problem number 4. A mixture contains milk and water in the ratio 5:1. On adding 5 liters of water, the ratio of milk and water becomes 5:2. The quantity of milk in the original mixture is 16 liters, 25 liters, 22.75 liters, 32.5 liters. Now this problem is similar to the previous one but a slightly simpler. Here we just need to assume one variable, that is x. The quantity of milk in the original mixture we can assume it as x units. Now a mixture contains milk and water in the ratio 5:1. So when the original mixture was having 6 units, out of those 6 units there were 5 units of milk and 1 unit of water. Now suppose the original quantity of water is x, then in that mixture original quantity of milk would be obviously 5x. Now what is being done here is just water is added. So originally quantity of water was x. Now when 5 liters of water is added to the mixture, so new quantity of water will be x upon 5. And now by adding water, the ratio of milk as to water is 5:2. So simply we can say this 5x upon x by 5 is equal to nothing but the given ratio, which is 5:2. So 5x upon x plus 5 is equal to 5/2. By cross multiplication we will get 5x into 2 is 10x is equal to 5x plus 25. 5x is equal to 25 and hence x is equal to 5. So now the x is equal to 5, that means quantity of water in original mixture was x. But what is being asked in the question is the quantity of milk in the original mixture, which is nothing but 5x. So 5 into 5 is 25 liters. So quantity of milk in the original mixture was 25 liters, which is our answer, option number B. I hope you have understood the problem and concept of alligation by now. We'll move to last problem of the video, problem number 5. 2 barrels contain a mixture of ethanol and gasoline. The content of ethanol is 60% in the first barrel and 30% in the second barrel. in what ratio must the mixtures from the first and second barrel be taken to form a mixture containing 50% ethanol. Now here just two mixtures are mixed to form a required mixture. Hence again we can simply apply the rule of alligation which we have seen in the initial part of the video. You can apply the formula either for quantity of ethanol or for the quantity of gasoline. Let's suppose now here I am applying alligation formula for ethanol. Now barrel first contain 60% ethanol, so we will write here 60, and barrel 2 contain 30% of ethanol, and resultant should contain 50% of ethanol. So mixture quantity is being written here. Now this 60 minus 50 is equal to 10, and similarly this 50 minus 30 is equal to 20. So required ratio is simply this 20 upon 10, that is 2:1, and hence we can say that quantity of the mixture from barrel 1 to barrel 2 is equal to 2:1. In this video we have seen 5 practice problems on alligation. In upcoming videos we'll see few more problems on new concepts. Stay tuned with Amruta's Blink for more content. Thank you.